Hi, this is David. I'm happy to share the second video in my playlist on the Tidyverse, and so I thought it'd be a good time to illustrate, or if you haven't heard of it, introduce the package that's called readr, R-E-A-D-R, that's part of the Tidyverse, and this is the package that we would use to import external files into our R environment as usable R objects, so that in the Tidyverse those would be called tibbles, but a tibble is just an enhanced user-friendly version of the data frame. The data frame, of course, is the most important rectangular object in R. Now, in a previous video, as part of the introduction to R, I've already looked at this function here called read.table, and I would just ask you to focus on the fact that it has a dot in it. That's the telltale sign that it's part of the base package. Read.table is part of the utils package, and the utils package is loaded automatically when we start R. So if you're just using a base R setup, like I am, base R with a R Studio IDE on top of it, if you're just using the base R setup to import files, then you're probably using read.table or one of its many wrapper functions like read.csv, which really just calls the read.table function, but it's smart enough to set a couple of these arguments to be appropriate to a file format that is comma separated value. So read.csv is a wrapper on read.table, but it knows that the separator here between fields is a comma because it's comma separated value. But it's just a family, from my perspective, it's just a family of the import functions that are built in R that we could call the read.table functions. Now, if you're using R, from my perspective also, you might as well just step up to using readr, even if you only use readr, right? Because we can load readr by itself with readr like that. So now I'm loading and I can use it. Or we can load the tidyverse, in which case readr will be loaded along with it. But we don't need the whole tidyverse just to use readr. And from my perspective, might as well do that because it does everything that we get with the base read functions, that is read.table and its family of wrappers. But it does many things better, and it does a few things additionally. So from my perspective, why not just load readr? In the rest of this video, I'd just like to hit 5 points. 1, conceptually, how does it work? 2, the advantages. 3, parsing the vector, because that's a key operation. The parsing of a column that is characters into its appropriate vector type. And 4, ultimately, this is what we're doing. We're parsing a rectangle into a data frame in R. And then 5, just a mention of the write functions, right? Because we tend to focus on the read functions because we need to import, but we also do have a corresponding set of write functions back, and it's good to use those. My notebook here contains an initial code chunk that's really just administrative because I want to show you an image that I drew, and then I just like to set the paths to certain files as variable types. And you can just see that readr has some great documentation, including it has some sample or example files, including here it has what's called a challenge.csv that has 2,000 rows in it and is kind of illustrative of a challenging file to import. So I'm just remapping those to variables. But here's my diagram that shows that I wanted to show you the 3 steps that readr does to import an external file. So the first is it parses a rectangle. So, right, you can imagine here, this may just be the upper left-hand peek into a larger rectangular window. And the first step is to take that external flat file and parse into a rectangle. And that's what I'm showing right here. We have whatever it was externally, it is now parsed into a rectangle with columns and rows. And you can see here, each of the cell contents are delimited by quotes. And I'm not visualizing a separator, but we can handle really any separator as long as it's somewhat consistent. It doesn't even have to be perfectly consistent. Right? If it's a comma separated value, then we would have a comma as a separator. Oftentimes we just have spaces as a separator, or we could have a tab as a separator. But after I've parsed it or after readr is parsed it as a rectangle, what we have is here a clean grid, columns and rows. And we've delimited in quotes here to signify that on import here, as a parse in a rectangle, they are strings or characters, if you like. And they are all characters or strings. So we've got the rectangle. And then the second step is column specification. Because now, if we think about this vertically, what do we have? They're all columns of strings, or really vertically, if we just use this, we would really have columns of character vectors. But we want to have a data frame or a tibble. And what is a data frame? Well, it may be easy to forget, but a data frame in R is really just a list of equal length vectors. So it's a list, but where each of these columns is of equal length, and then each of those column types can be a different type of atomic vector. So we can see here as part of the second step, column specification. Well, as humans, we can look at this and go, okay, this is going to be, I'm just going to use shorthand. This is obviously going to be characters. So we want this to be a column, to be a character vector. And then we can look at the next column, which again, as of the first step, is just part of this parsed rectangle where everything is a character. But now we're looking at the column going, what do we want this to be as a vector in the data frame? What type of atomic vector type? Well, we can look at that and go, that's going to be logical, or sometimes called Boolean. Third one, this is going to be a number. I'm going to use N for numeric. Numeric actually is actually includes two types. Numeric is both integer or double, which stands for double precision floating point. But so we can see in this case, it's actually not going to be integer. It's not going to be quite enough, probably, because we're going to have currency. So we're going to need double. So I'm just going to say, but double is numeric. So I'm just going to say n sub d, numeric specifically double precision floating point. And then we can look at this as humans and conclude that this is probably dates. So that second step, right, would be specification of the column. And then the third step really is just that vector parsing. So parse each of the vectors. Parse each vector. And that step really, once we've done the second step, specified the column, then R just needs to come along and say, okay, what I've got, or I'm sorry, readr needs to say, okay, I have here what is, as of step 2, it's really just a column, a vector of character type, and I'm going to parse it into a vector of character type. But this column here, it's a column of strings or characters, but I'm going to parse it into a vector of logical type. I'm going to take this column and parse it into an atomic vector that is of numeric type, specifically double. And I'm going to take this column, which heretofore is a vector of strings. I'm going to parse it into an atomic vector of type date. And then having done that, we have done all three steps that really are required to define this as a data frame, or specifically in the tidyverse as a tibble. So that's the basic steps. Then the advantages, what I did with the various sources is pulled together the advantages. So I think I got them all, but I'm not 100% certain. And then here they are. The first one is that readr uses the UTF-8 everywhere to encode the data. So encoding is a whole other topic, but these are characters to us as humans, right? The C or the 8, or even symbols like Greek mu would be characters. And those characters need to be mapped under some encoding scheme to bytes that the character can understand, or ultimately ones and zeros. And so there are lots of different encoding schemes, but UTF is the best, including it's backward compatible to ASCII format that some of us older folks are familiar with. So this is a nice feature that we just don't need to worry generally about deviating from the UTF 8 encoding scheme. 2, typically I read that the readr functions are much faster than the base R. 3, as mentioned, we produce the tidyverse tibbles, which is also as part of the definition. They are data frames, so they're backward compatible, so to speak, with the built-in R data frame, but we get the advantages of a tibble. 4, there's a couple of things in the base read table function that are just annoyances to some of us who have been working with it. It automatically converts vectors into character vectors into factors unless we set this strings as factors false, which we're always constantly doing. So we always have to worry about that in base R. Don't need to worry about that in readr. It's smarter than that. And readr also doesn't mangle the column names, which the base functions apparently do. Finally, it's more reproducible because these base R functions have a tendency to inherit behaviors as part of the operating system or environmental variables, meaning that occasionally sharing your code with someone else on a different operating system will make it not work. But we don't have that concern here with the readr functions. Okay, so number 3 in terms of parsing the vector, right? That's that third step in that 3-step process that I illustrated. Well, readr comes with parse functions, and you can see each parse is coupled with a column function, which will be used in the process of parsing a complete table. And so that family includes parse logical, parse integer, parse double, parse character, parse factor, and then also we have date, time, and date time. So just by way of example, what we mean here by that, what we mean by parsing the vector, I just define here a variable character1, and that you can see shows up here. So that is a character vector of length 4, right? It doesn't matter that I've got the logicals in there. I have delimited them with strings. It's coming in as a character. And then right here, I'm using the parse logical function simply to parse that vector and defining it into parsed character1 such that if I come down here and take a look at parsed character1, you can see it's a logical vector of length 4, true, false, and a true. So that's the function of the parse logical. And if you can imagine, we might then have been performing that third step as part of the readr function and importing the file, right? The external file has already been parsed as a rectangle so that all the cells are strings. Then maybe one of those columns, if I'll go back up here, that second column in the second step has been specified as a logical, that it should be logical. Well, then that third step at that point would here be using the parse logical function to parse that character vector into a logical vector. And so here then I have character 2, 1, 2, 3, 4, that I can use parse integer on. And we could see the structure of that string parsed character 2 is an integer. Here, now on the other hand, I'm going to take character 2 and I'm going to replace the 3 with a period. So in terms of defining that character vector, no worries. Character vector are really the most flexible type. Now, what happens though if I run parse integer on it? Well, I get a parsing failure. And I do have here included in the readr functions, the problems functions, which is really cool, I think. It will report back to me if I pull down here. It reports back to me that it had a problem in row 3 where it expected an integer but actually got a period. Right? And I'm not too surprised there. I defined it that way. How can I overcome that, having seen the problem by running the problems function? Well, simply by adding this argument here. So I can still parse, I can still take that character vector, run the parse integer, so parse it all as integers, but the NA param here, and I'll pull up, let me just pull up the help here. And I'm going to pull up the help on the on the base function here, readr, readr as part of the read package. And then if I come down here to my arguments, NA, character vector of strings to interpret as missing values. So by adding this argument, I'm telling it that when you parse, if you encounter a period, that's going to be an NA. And now if I've done that, R won't see this as a problem at all, or readr won't see this as a problem at all. And I can take a look at parsed character 2, and you can see it has parsed that period into an NA per these instructions, and I have no problem. So parse number is really cool. It's smart because, as you probably know if you've imported files at all, the numbers oftentimes have some extra junk around them, like even just a $100. Well, that's obviously a number, and parse 100 is smart enough to know that, but also smart enough to know that if we have something like the price is a $100, that's also 100, so is 20%, and so is even the cost is $99.95, comes in as $99.95. Okay, so number 4 on my list, readr's rectangular parsers. So that's the essential function that we're doing, right? We start that first step and finish with the third step by calling one of readr's functions. So I've already pulled up the help on readr, and I did that because that's the base function. So from my perspective, that's the analog to read.table in base R as part of utils. And then read_CSV is the analog to read.csv. So that's why I was just highlighting the difference between the underscore and the period, right? That's the telltale sign. I've got read.csv at the moment as part of my base, but I might as well use read_CSV as part of my readr, comma separated value. Although the analogy continues, my read_CSV is just a wrapper on my read_delim. And so if I have a tip for you, my tip would be to try to get as comfortable as possible with just looking at the help file. Right, I'm still getting better at this, but really if you get stuck, a lot of the answers are over here in the help file, in the definitions of the arguments and so on. So I copied a bit from the documentation here, just to highlight the strategy. readr uses heuristic to figure out the type of each column. Oh, so I put this in because you may be wondering about that. You might have wondered about the column specification. How does R know, or do we have to define each column type when we do that second step of column specification? Well, what's really great is that R is smart. It invokes this strategy such that if you have a relatively clean flat file, in most cases, you don't need to worry about specifying the column. That second step is performed automatically by readr. Very cool. And that's because the strategy here is it reads the first 1,000 rows and uses some moderately conservative heuristics to figure out the type of each column. And you can emulate this process with a character vector using guess parser. So it actually has guess parser and parse guess functions if you want to take a deep dive on that. But for this purpose here, if I run readr.example, I get the example files that are bundled into the package. And then I mentioned that challenge file is a .csv that is a challenging 2,000 row file. And it's challenging because it has 1,000 rows and then it changes the format on the next 2,000. So if I run a read_CSV, and again, that underscore signifies that I'm using the readr function, then what I get here are some feedback from the readr. And this first part is really a helpful feature of the readr function. It's telling me it parsed with these column specifications. So you see how we're getting that feedback? It went to work and we got 2 columns, and it specified based on that heuristic, the first column X it's specified as double, and again, that's a numeric type, double point floating precision. And the second one, it's specified as logic. I think even in the last update, I think I read that even they added, this is new, adding the color coding of the types, so just very helpful. And then it's telling us that there were 1,000 parsing failures, and in this case, that refers to the second 1,000 rows. So we could run the problems on that challenge, see how I ran read underscore CSV. So I basically imported that comma separated value into the challenge, and you'll notice it shows up here in, it is a data frame, or because I used underscores, because I used the readr function, it's a tibble. But you can see it was basically a success in the sense that I've imported the CSV into a data frame or tibble here, and I can take a view of all 2,000 rows. But I do have the problems, and I can run the problems function to actually get a list of the functions. And what am I getting here? Well, I'm actually getting a data frame that just shows me the problems of the import. And when I first saw that, I thought, that's really cool. Wait, how are they doing that? Well, of course, it's being stored as an attribute of the data frame, right? So I can go, or actually I could just look right up here. Well, I could run attributes of challenge, and it goes by pretty fast, but what I get is I get right here, and the attribute is problems is itself a tibble with 1,000 rows listing my problems. So attributes are name value pairs that are attached as metadata to my object, in this case my challenge object. So that's just I think that's also very cool, the fact that although in this case my import was successful in the sense that I got the first 1,000, even my problems, my second 1,000 that were problems that were not really imported successfully do get attached as metadata, metadata as an attribute of my object. Okay, so having looked at that, then I can then rerun the challenge, and so that's the command I wanted to show you. I'm using read underscore CSV, giving it the location and name of the file, which I've already stored as a variable, and then I'm using this command right here. I'm column underscore types equals calls, so I don't need to use this if I have a relatively clean flat file that I'm importing, because readr is so smart. But in this case, having that problem, I'm overriding it, and I'm telling the readr or the read underscore CSV that I want that first column to be double and the second column to be a date type. So now, if I run that, and then I'll just use the RStudio. That's in fact what I'm going to get. So I've addressed the second 1,000 that were previously problems to this. So then there's a lot of parameters in the read underscore CSV, and I'm highlighting read underscore CSV just because I think, I can't speak for you, but in practice, again, that is a wrapper, but in practice for me, at least that's the one I've been using, because so many of these external file formats are ultimately saved as comma separated values because it's quasi-universal. So we have a lot of arguments there, but I think the most important are the file name, if we want to override with a delimiter, but you can see the default there is to delimit that comma separated values. By definition, the delimiter is a comma. Then are they contained in quotes? And so you can see here the default is actually a quote. We need to escape it. I've talked about that in a previous video. Comment. We can signify the comment character such that any text after the comment character will be silently ignored. I showed you column types, so that's very important if you have a problem and you want to override it by defining the columns, and then column names if we want it. And then the NA, which I also demonstrated. If we know there's a character type that we want to specifically tag that to be parsed as NA on import, or on parsing, I should say. So that's so that's basically what I think are the important arguments as part of the read_CSV. And I have my own more simple case of the Cloudera, some stock price history that I downloaded, I think, from Yahoo as a comma separated value. And so that's where it's located. And if I just run read_CSV on that comma separated value, what I get this nice feedback parsed with column specifications. So you can see how I didn't even show you that Cloudera stock price history that I downloaded from Yahoo Finance. I didn't even show you that. But I'm getting here the feedback here on running the function that gives me at least a picture of the columns. I can see date, open, high, low, close, volume. And with the color coding, I'm getting an indication as to how it pulled it in. So I can see it pulled in that date as call_character. Although I didn't give it a name, so let me just call it, give it a name right there, Cloudera, so that I can look at it. Now I can look at it when it's imported. And import is successful. I do have a data frame, or in this case, a tibble. And I had added a column here where I had hypothetical trades, a buy, and then I had periods and a sell. And that's because I just wanted to show you, well, okay, those came in, and per the parser, right, these trades, it imported them as we might expect. It couldn't do any better as character, so that it's getting treated as a character vector. But I've got these periods, and maybe I want them to be NAs. So if I just come back here, that's why I've got these other commands down here where I just said NA equals, I add that, rerun it with the argument. So NA equals period, and then I don't even need to refresh that. Is how cool RStudio is. You'll notice it did the job. It's treating all those other values as NAs. And then finally, just to remind that read.csv is a wrapper, right? So I could have done read.delim of the same file, although, and then just, you can see I've got this delim argument, and then I could have just have explicitly defined the delimiter as a comma, keeping my NA argument. And then if I run that, I really get the same effect by using the core function. So there's also read.lines and read.fwf. If I run read.lines on the, this is just my variable name for the sample, the FWF sample text that comes with the readr, and read.lines reads those lines for me so I can see what this is. And I can see this is a flat file, FWF sample, in the readr package built in, but just for hypothetical purposes, illustrative purposes, could be from anywhere. And I can just see what the file is. It's flat, and it looks like there's using space here, but actually more than space, it's fixed width that's separating these fields, and which will ultimately become columns. So I can use, knowing that, I can use the read_FWF, and let's see if it's down here, or let me pull up the help, read_FWF, read a fixed width file into a tibble, so I have the help there. And I'm reading that in, and then I'm setting the argument FWF_widths to, with a vector of those column widths, 20 characters, 10 characters, 20 characters, and I can even give them names as well. so that if I run that command, you can see what I get here is the parsed, that fixed width file, which was a .txt, is parsed for me, and it's even named. So that's handy if it's fixed width. Then finally, just a note that we have the write functions, write_CSV, write_TSV, and even write_XL_CSV. Both of these functions increase the chance of the output file being read back incorrectly by always encoding the strings in that UTF-8 encoding scheme and saving dates and date times in ISO 86001 format so they are easily parsed elsewhere. So that's really the 5 points that I wanted to make about the readr package, which contains the let's go back here, which contains the read_delim and the wrapper functions, which are all betrayed by this read_ syntax. And I hope that's helpful. If it is helpful, then subscribe to the channel and you'll get notified of my next video. Thank you.